Do I now have sound?
Do I now have sound? Do I now have sound?
Indeed, I do. Okay, it's back. So after that little adventure in trying to get sound working, I discovered it was a combination of OBS got the wrong idea, and yeah, OBS got the wrong idea, and my some other problems. There's a got this thing that the Arctis Pro Nova Elite recently, and one of its interesting issues is if you're connected to Bluetooth, it won't send sound to the base station. It will, I think, it only sends the mic input to the Bluetooth uh, person, but it talks to more than one Bluetooth device at a time. I don't know how it decides who, in fact, gets to hear the microphone. Uh, and I don't know why it was connecting over Bluetooth. So anyway, now it's all sorted. OBS is set up. Let's get back to programming. So last time I was messing around with the formatter and I got something to work, but I was dissatisfied with what I accomplished for a number of different reasons. And so I decided that what the heck, I am going to make something that actually works properly. Um, going to make the formatter work the way I want it to. Because it irritates me when I have to compromise because I don't fully understand how something works. And even now, I don't actually fully understand how something works, but I understand it a lot better than I did before. Um, uh, too many things bleeping at me, including a notification from YouTube that I'm online, which, I mean, that's nice to know, but I kind of knew that already, you know? Let's see here. Think. Anyway, as you can see, I've been running some experiments in Compiler Explorer because of its quick feedback. The only problem is the format library is very compiler intensive. It causes compilation times to shoot through the roof, which is pretty annoying. Um, hmm. So here's what we're going to do here. We are going to copy over some of what we learned from Compiler Explorer. Um, so going to do this. This has to stay here, sadly. Um, although, no, it has to stay here. The reason why it has to stay here is because const expr functions basically have to be available in uh, their full form. All of their source code has to be here because they have to be executed by the compiler at compile time, in any number of situations. And this parse function very definitely has to be executed at compile time. That's the whole point. So parse context. Um, we're going to do that. And then we'll have and name all the types explicitly, and then we'll just get rid of this thingy here. Then for this one, go back over here to Compiler Explorer to my little experiment. There's this page, but this page is wrong. And one of the very vexing things that it's wrong about is this function is supposed to be const. And when it isn't const, the error message, you get no coherent error message out of any compiler. I don't know if Rust would be better about that. That's a thing that I really, really dislike about C++ is that many times in template programs that make heavy use of templates, you get no reasonable error messages. One of the highly amusing things to me about that is the whole idea of what are these called now? Oh, I added the stuff for it in here someplace, and I forgot what the name was, but I make use of them. Concepts. The whole point of concepts was to try and make the error messages better, but as near as I can tell, concepts have made the error messages worse. I get no coherent sense of what I need to do to fix something, like what is wrong with the type that I'm passing in uh, when a concept fails. Uh, it is obnoxious. So, um, that's for this. And then I have this one here. And this is, I'm going to move this function into a CPP file. And again, not about that part of it. No, no, no. Come on. Like that. And now we can take this print visitor. We can do all kinds of things now because we can make this function because it has a very definite type signature. Not going to implement wchart because wchart is basically meaningless in C++. There's no particularly good reason to use it. C++ is in desperate need of like maybe code point T or something like that. Because char T is, yeah. wchar means different things on different platforms and it's just all wrong. So it needs to be code point T. Token debug. And so we can now except I don't want, oh, yes, yes. And except print visitor no longer needs to be templated on the format context type. So we're just going to, yeah. And we'll change it to T just to be consistent. There. All right. Now, what we're actually going to do is we and we'll put these usings are going to appear in this CPP file, right? And no, is that how this works? No, 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 no. So why does it not like this? Yes, it's already been declared. It's not, okay, there, the red line finally went away. So let's try doing a build again. Okay, that worked. Okay, so now I can take all of this stuff and actually move it here. All right, let's try building it again. There we go. Now I want to know what happens if I try and print something out in a certain way. So first, so why this fails, I don't know. Like this parse should not fail. This parse should succeed, and I'm not sure what's going wrong here. But uh, that's neither here nor there. Like we look at the tokens that we're getting out, and yep, keyword var identifier equals 5, semicolon, file. Yep, so all that works. And if we try and build the run this target, all the tests still succeed, but if we then force one of the tests to fail, do we get a coherent error message out now? So parser CPP farming test. Lexer test. I need to convert this to the tokenizer test. That's what I wanted. Um, I've actually misnamed these the enum values here. It's not bool and, it's Boolean algebra and, but not Boolean logic bitwise and. I guess I could call it bit and bool and. I guess boolean. I'll leave it at boolean. Now let's see here. Now, if we run it, we should get an error here because this is going to be equal and boolean, and I should get a coherent listing out of what the tokens are. Indeed. And then when it tells me, I get identifier equals unsigned integer plus. But here, identifier log and, logical and. Yeah, but basically, yes. And it's doing all, otherwise, it's doing all the right things as far as like, yep. All right. So The formatter works. And there's one other thing I want to test here. Um, which won't be in release yet, but so all these tests are correct. Let's change our build type to release and then run all these again, which means I'll have to rebuild everything. But there we go. And indeed, all the tests also succeed in release mode, which they'd better. Yep, that's okay. That's what I was expecting. They're both exactly the same size, which is also what I was expecting. I actually wonder whether they have the same inode or not. They do not. That's kind of amusing. Hello there. I'm writing a programming language in C++ and using CTRE to do all the lexing, which is what the original genesis of the project was. But now today I'm messing with C++'s formatting FMTlib. Well, basically the C++ standards committee decided to make a really popular library, libfmt, for C++, decided to make it standard. And so I'm experimenting with getting the tokens to be printed out using this formatting library. And right now, I want to know why this file is so big. What's in it that's so big? So, obj dump. Um, let's try -d, disassemble. There we go. So what symbols do we got in here? Are there you C++ people? We have, okay, this is basically just a duplicate of something from the standard library. So a lot of this is code that's effectively duplicate code, which is what I expected. That's one of the reasons why it's so big. C++ modules will fix a lot of that. This is also duplicate code. Huh. Well, that's very interesting because any token, oh, I see, because it's a, there we go. Well, what symbol is this? Oh, hi there. Oh, person with the actually I hope that you did as well. I actually learned where you got your picture from, and then where you got it from slips my mind. But I remember seeing the picture and seeing how there was like a project to recreate it, and obviously you were part of that project to recreate it because that's what you were trying to do. And yeah, I'm. Where was that from now? I can't remember, but I saw the picture and I thought of you because uh, well, I liked your version because I think you showed me your version. You did a pretty good job with it. Um, wasn't an exact reproduction of the original, but it captured it pretty well. Um, but the thing I was curious about is like, what was the? It was like somebody generated some AI something, and then it's like, so how do we duplicate this using Blender? How do we actually make this into a game environment that you can be in? And I can't remember like where that came from. I remember reading something about it though. Hello there, a cheese man. I'm doing pretty well today. I'm having fun doing a bunch of C++ programming. Let's see here. Tokens colon colon. I'm trying to figure out what function I'm looking at here. Symbol names in C++ can get to be ridiculously huge. I think this is the actual format function, but I'm not positive. This is so annoying. Whee! Anyway, the reason why the file is so huge is there's a whole big bunch of duplicate code in it because C++ does that kind of dumb stuff. Um, it it implements duplicate copies of a whole big bunch of your inline functions into every single file in which you even glance at the inline function you care about, and they all get combined into one copy by the linker, but the object files can end up being pretty huge. Ah, okay. That makes sense. And today's project was moving all of this stuff into a CPP implementation file instead of having it in a header file where code got duplicate so that the code wouldn't get duplicated all over creation. Because I want to make this a lot more complicated um, at some point, and so I want to make sure that this code doesn't get duplicated all over the place. Um, so I moved it into a CPP file, which was trickier than I thought because the original thing required that they be templates because people didn't know the actual names of the types that these things took. And so I had to figure out what the names of the types were. And this one can't be moved. The parse function can't be moved because, in fact, it has to be accessible at compile time everywhere where the formatter is used because it is a const expr function. And the way the format library for C++ works is, in fact, the compiler parses the format string at the time that it sees the format string. Like when the compiler sees this, right? When you do format2 and the compiler looks at this, at compile time, the parser is actually parsing the string and matching the things up in the string to your parameters. And then you could put like all kinds of little modifiers in here to change the width and all kinds of stuff. And that all happens at compile time. Um, and so this parse function is the thing that figures out what's inside these braces here. What does that mean about how I have to format stuff? And of course, because it needs to be evaluated at compile time. That means it needs to be available everywhere. Everybody has to be able to see it. You can't just stuff it in a CPP file and forget about it. How was your Christmas and New Year's, Z43? All right. Actually, I'm kind of curious as to what happens if I do this. I'm betting that this will in fact fail to compile because of the way the format library parses this stuff at compile time. Yeah. Yep. It's going to go that I don't understand that format. On the other hand, if I did this, that would work just fine. Right? And that would work just fine because all I'm really doing is saying use parameter 0, and then the rest of this gets passed at the parse context, but parse context goes, I don't want to do anything with it. And that's just fine because there's nothing to be done. There's nothing to do anything with. And so everything's happy. So, yep. Are any of you familiar with how much stuff C++ does at compile time? Role of const expr in C++ programs? All right. Okay. Now that we've done this, there is a bug that needs fixing. And it is a complicated bug. And it's in parser. And it shouldn't be in parser. I need to split up parser because it's starting to get too big. Oh, well. They both left. Hello there, Valdium. How are you this fine evening? So, what is the error? I explained this to Sir Elfman, who is currently not here. Last time I was streaming, which was on Tuesday, and the error is kind of complicated. Here's what's going on. The parser keeps activation records for the. So actually, I have an evaluator that evaluates the abstract syntax tree the parser produces. The parser reads in the program, produces a data structure describing the program as right, so that it isn't just a bunch of text. It's like a structure going, yes, we have an operator and it has these two arguments. And that argument is actually another expression that is this thing that can be evaluated, and so on and so forth. And so there's a evaluator that actually can go through the abstract syntax tree and basically run the program. It goes to every node and figures out what that node's all about and produces a value for that node. And then, if the node happens to be plus, for example, it evaluates both subtrees. If the node happens to be the plus operator, it evaluates both subtrees, and then it adds the results together. So like here, right? Binary operation is one of the kinds of AST nodes, abstract syntax tree nodes that can exist. And if you get to a binary operation node, what you do is you evaluate the left-hand side of it, you save it, and then you evaluate the right-hand side of it, and then you save it. And then if it happened to have been a plus, you set the current result, which is the kind of the running current, the most recent value that you manage to come up with in your evaluation of things. You set the current result to the one plus the other, right? And the same with all of the other ones. And all of these things are all logical or relational operators, and so they have a one or a zero as a result because there's only two data types in the program. The two data types are unsigned 64-bit integer and function. Those are the only two data types. And this one should never be evaluated for, uh, yeah, this should never be evaluated for a function right now. So that's interesting. And I don't know whether I have encoded that particular restriction into the parser yet, because the parser will know at parse time the type of the identifier. And so it can actually flag the expression at parse time going, you can't do that with these types. But simple evaluator, identifier, da, 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 da. So the problem was in function calls. So in statement list, and actually what I'll do over here is I will pull up parser CPP over here and keep statement list up while I go down over on this side over to function call. So statement lists. Oh, let's go to the parser so we can actually look at the simple evaluator's data structure. What's in a simple evaluator? So one of the things the simple evaluator is keeping is it's keeping sort of the execution stack, the stack of the list of activation records, which in a programming language like C or Java or C++, any number of languages is called the stack, because that's its implementation. It's implemented as a stack. But some programming languages like Python, I don't know about Ruby. I suspect Ruby is, in fact, I'm not almost positive Ruby is this way. Any language that actually supports something called closures has to actually not use a stack as a data structure for activation records. It has to use a tree instead. Um, won't get into exactly why right now, but I'm using a stack, partly because I don't support closures. Well, I guess Valdium wasn't very interested in the explanation. Um, but so closures, closures. What was I saying about that? Okay, I don't support closures. Uh, just a bit. I have somebody. So I don't have closures, and I implement things strictly as a stack. And here is where the stack is. The var values. Every stack frame contains a vector of variable values. At compile time, or at parse time, as the program is being parsed, at compile time, although it isn't really compiled, it's parsed into an AST and the AST is evaluated directly. But at parse time, it assigns each identifier in a scope to an integer variable slot. And that's just that. It knows what slot the variable is in the stack frame and the appropriate stack frame. It knows, okay, there will be a stack frame that I can access variables in, and in that stack frame, there are going to be slots for the variables, and this variable will be in slot blah. And so every stack frame has to have a list of all the variable values, slots for all of them. And so that's what this is, a vector of varval_t. Varval_t is currently a variant. It was just uint_max_t. I made it a variant because I needed to be able to store functions in it. After I implemented the ability to declare functions, I had to be able to store functions as variable values. Yeah. So this is the stack right here, right? How are functions implemented? So functions, of course, will create a brand new stack frame when they execute. That's part of the nature of functions. But what's going to be in that stack frame? Well, if the function has arguments, the function's arguments are going to be in that stack frame. And if the function has local variables, the local variables are going to be in that stack frame. Now, what I could have done is I could have created a stack frame for the function invocation, and then another stack frame for the body of the function. That's one thing I could have done. And then the stack frame for the function invocation would just have the variable values. But that would be really, then I would have had to attract that as a, I didn't do that. What I did do is I just have a stack frame for the function arguments and its body. And I just reserve the first n slots for the n arguments to the function. And so, but the function arguments are evaluated before the body of the function is entered, before the statement list for that function is entered, and statement list is where the stack frame is created, right? So before the stack frame is created, I'm evaluating arguments. So I have all these arguments lying around that I need to stuff into a stack frame that doesn't yet exist. So I'm saving them. This is where they get saved, right? There's a problem now. Like here, where I'm evaluating the function call, okay, I go through and I have a bunch of function arguments. And then I go through the list of, the expressions for the parameters to the functions, because each parameter to the function is an expression. And then, I find out what happens when I evaluate that expression. I visit that expression. And then I put the result, the value I get out from evaluating that parameter expression into the function argument list as one of the function arguments. And then I assert that that we actually do have a body, which it should be impossible for us to get here and not have a body. That's the reason why it's an assert. Then I visit the body. Well, notice here in the parser, the first thing I do is I look if they're not the variable declarations isn't empty for the current stack frame, which it won't be if there's any arguments. Then I put I create a new stack frame, right? And part of the argument to the stack frame is the static scope of the variables that are in that stack frame. Then I assert that that the construction went well. That when the stack and added a new thing onto it, when we created a new stack frame, that the stack frame was set up correctly, essentially. Um, then I assert that either the function arguments are empty or that the uh, variable declarations, the number of variables slots that we have for this stack frame, the number of variable slots that we have for the stack frame is at least as many as we have function arguments. Um, and blah 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 blah. This is redundant. Well, it's yeah, it's redundant. I'm going to leave it. It doesn't matter that the redundancy doesn't matter. It's a redundancy in assert. It doesn't matter. Um, because if this is 0, then this has to be greater than or equal to the size. Um, so it's redundant. The or the condition on the left hand side of the or will always be true on the right hand side of the or, and so I can just have the right hand side of the or instead. Um, if funcargs.empty. So if we actually did have any function arguments, then I copy in the function arguments from I copy the function arguments into our uh, variable slots, into the first n variable slots, and then I clear them, right? Because I consume them. Because then if I have a function call inside this one, then inside inside the body of this function, I call another function, and then the func args have to be set up again, right? So I clear is consuming the function arguments. There's a problem now. While evaluating here, I could be calling a function. Like I might be calling a function as part of evaluating a parameter. The parameter might be the expression for the parameter might be a function call, in which case funcargs already has some stuff in it, right? So I need to do something else. What I'm going to do here is I'm going to say, this assert is correct. A funcarg should be, but what I should do instead here uh, yeah, like that. And then here I do And there we go. So now what I'm doing is I have uh, the arguments are a local variable instead. They're on this stack right here. And then I accumulate them into this vector that's on the local arguments, that's inside this function. And reserve space for it, so I'm not doing any reallocation because I know exactly how many I'm going to end up with. Um, oh, indeed, it should not be constant. There we go. That solves all the problems. Um, so then I reserve the appropriate size, go through all my function arguments, and then I should also say like that. So a bunch of asserts, and then I just set funcargs just before I visit I run the simple evaluator here, for the statement list before I jump into my function body. I set up funcargs. So then there's no time for funcargs to be needed by anything else. Because right here, this is a spot where funcargs, in fact, might have been needed by something else, because there might have been a function call as a part of a parameter expression. So this sets it up so that funcargs, the lifetime at which funcargs is relevant is much, much smaller. Um, and so there's nothing that's going to need to stump on it to be able to use it itself in between here and this visit, because the very first thing in here is setting up funcargs. Uh, anyway, this just preempts an error. It's interesting that parser.cpp is so quick to build compared to anything that uses the format library. I really need to get modules working on here, because if I get modules working on here, the compilation time for the format library will go stuff using the format library will go way down. Anyway. There. All right. Now, now we have a bunch of work to do, and I'm going to stop streaming now and do the work later. The work is going to be, yes, we have this parser and the evaluator and all that stuff set up now, but there's nothing that's going to call any of it. I don't actually look for uh, uh, function declarations or function calls inside any of the rest of the parser. And so it never tries to parse those things. And so everything continues. It's a bunch of code that's effectively dead code. So that will be next stream's project. I wish you uh, all of my ghostly not viewers, I wish you all a good night and happy New Year's, everyone.